So in this video we will see how we can draw the layout of a Mosfet, both Pmos and Nmos. Before that we will just see the general structure of Mosfet, Nmos and Pmos. We have a P substrate and a gate N plus and N plus. This will form the Nmos over the Pmos P substrate, and the thing is that this N plus and P forms a diode. So to make this diode always in reverse bias, what we can do is connect this P substrate to a voltage, to the minimum voltage that is available in our circuit. So here it is ground, so the substrate should be connected to ground. Normally we connect a metal layer here, then what it do is this metal have high conductivity compared to P substrate, so it forms a Schottky diode. To avoid that problem, you just add P plus diffusion here, so this will avoid that Schottky effect. Now it reduces the resistance so that you can have a contact with P substrate. Now you connect this metal to the source and connect it to ground. So we have for Nmos N plus, N plus, N plus and P plus. This forms the Nmos. And in the case of Pmos, we have P plus and P plus, which is inside the N well. So in a P substrate, we first want to make an N well. Inside that you make P plus and P plus. So this will form the Pmos. But as we know, this N well, in this case P plus and N is here, it also forms a diode, PN diode. So to make this in the reverse bias, what we can do is always give a high potential to this N well. So we always connect VDD to this N well. So to make that connection, we make a metal contact here, but as I told, it again forms a Schottky diode. So to avoid that, you use an N plus here, so it reduces the resistance and works well. Now this metal and this drain we can connect to VDD. So we have P substrate and N plus, N plus and P plus for the Nmos, and in the case of Pmos we have P plus, P plus and N plus in a N well. Now we will see the different layers that we are going to use for the layout of a Nmos and Pmos. First one is the poly, then we have active, then N select. We have two more things, that is the P select and N well. First you draw the active, that defines the width of the transistor. Then place a poly. The length of the poly determines the gate length. What it actually do is, we have P substrate, over that a thin gate oxide, and the thickness of the gate oxide decides the TOX of the technology. And if we form the active over that a poly, it forms a self-alignment process. It means first this poly will be deposited over this oxide layer. This is P substrate and we have oxide layer, over that we have a poly. Now this active, wherever you can see the active, there etching will happen. So it actually gives an opening to the gate oxide. An opening will happen at the gate oxide and you can directly go to the P substrate. Now we have an opening here and here, and if we place an N in N select or P select, what it do is, in the opening it will deposit N plus and N plus or P plus and P plus, depends upon the layer you selected, whether it is N or P. That is how we get N plus and N plus here. Now our next thing is, we want to connect this substrate to the lowest voltage. So we want to make a connection from here. How we can make that connection? Make a P plus here, then contact these two, you connect to ground. for that purpose, what we can do here is just stretch this and active to some more here, some more here. You stretch it and place a p-select layer. So we can have opening here in the oxide layer, and you can deposit p plus here. Okay, so we have Nmos. If we want Pmos, select the p select instead of n select here, then make stretch this active and place n select. So we have p plus n plus here. Now it should be inside a n well. So after all, put a n well, so that will make Pmos. Now we will see how we can do the layout using the Glade tool. My Glade tool is here. So this is the Glade for underscore win 64 is the extracted file for the Glade tool. Open this, then you can see a Glade here, glade.exe file with a symbol. Open it. Opened. Go to file, new library, give a name to our library. I am giving inverter as name to my library. Load text file. Now go here, click on this, then go to our ENGR3426. it have a text file .tch file. Open this. Open. What is this .th file is? It have all the information about the layers which we can use in this particular technology, and it will say how many metal layers we can use. All that layers will appear here in the LSW window. You will see that thing. Click OK. Now go here, new cell, that library is there, inverter. Inside that again I am writing the same name. You can give different name here. So click OK. The setup came. See here, LSW window is there. You can see all the layers what that we can use it for our layout from this particular technology. Now go to view, display option is there. Go to display setting, make it dotted. If other than something is there, you make it as dotted. Click on that and major 4, minor 0.3, 0.3. If you have something else there, means you change this to this setting. Go to snap setting, make it 0.3, 0.3, then miscellaneous, and if some tick is here, means remove that tick, then click OK. Setup is there. What I have given there is 0.3, 0.3, everywhere 0.3, and major grid size is 4. The meaning is you have a major grid which have 4 minor grid, 1, 2, 3, 4. So it's a 4 into 4, and each minor grid have 0.3 into 0.3 micro. So from this point to this point we have 0.3 micro. From this point to this point also you have 0.3 micro distance. Now create, verify, tools. If this LSW window is not there, that actually shows the number of layers and the layers that we can use it. If it is not ticked, you just tick it. And message window is there. This is the message window. It shows the result of each action we have made in this tool. And library browser is there, that is here, that shows on which library we are working. Now we are working on inverter, and inside inverter I have opened a new window, that is the layout window. So here you can see inverter layout. So if it is not there means, and if you want to see that, tick that thing. That's it. These are the major things we want to have before starting our layout. Now I will show you the layout of Nmos and Pmos transistor. And the thing you want to keep in mind is that the minimum length of the transistor in this technology is 0.6 micrometer, and the minimum width of the transistor is 1.8 micrometer. That is the minimum width and length criteria for both Pmos and Nmos, and you can have any larger value than this thing, that is not a problem, but minimum you have to keep these values. So I will show how we can draw a Nmos transistor. So go to here, click on active. Now as I told, we should have 1.8 micro as the minimum width. So each point is separated by 0.3 micro. So such as 6 blocks, you select such as 6 blocks. So I start from here, click on this, then the point from where you want to start, there you go and click, then press the key R. Okay, then you move like this, select the grids. Now it is 6, selected like this. Now go and take poly, and somewhere here I am starting, click on that and press R. Now poly will be formed. Okay, now you take the contact. So I am placing one contact here, click on that, press on and press R to make contact. Now the minimum distance between poly and contact is 2 unit, I mean 1 lambda. If you take this as lambda, 1 lambda, then go here, select that thing, press M, then you can move this. Now I have made 2, 2, 2. This is also 2 units. Okay, now I make one more contact here, from here, then go select that point, press R, then you select it. Okay, now again a contact I made, but here I can keep 2. If more than that means no problem, but I can keep 2 there. So select this, then what you can do is select F4. Okay, then click on one side. It is not selected, one more, F4, select, it's not working. Okay, now after that press, you can select only one side. Now I press the key S so that I can stretch it. Now you freely move this. Now it is 2 unit. Okay, 2 unit apart, 2 unit apart. Now this selection is only for one side, so to avoid that selection, again you press F4. Okay, now you can select the entire thing. Okay, now what you can observe here is, you can see this black area as P substrate over that silicon dioxide. Okay, now if I place this active, what it do is, it will etch that silicon dioxide area and it will give an opening to substrate. Now if I place N select, go here, press R, N select. Now what it do is, it will make N plus here and N plus here, but under the poly you have the gate oxide, because this poly will protect from both etching and implant. so it will protect this area, so nothing will happen underneath this area. Now you want to have a connection to this substrate. This black area is substrate, so you want to have a connection to that substrate. So what I can do is I can just again go here, F4, press F4, then select an area, select this side, press S, then move this. Okay, stretch that thing, then again press F4 to deselect it. Okay, then make a contact, press R, will form a contact. Okay, now move M, I am keeping 2 distance here, and this one again I am stretching 1 unit here. Okay, again pressing F4, so deselection will happen. Now what I can do is take P select, click on here, press R. Now it formed P plus, then N plus and N plus. Now Nmos is ready. Suppose you want to make Pmos, what you can do is same thing. I told you 0.6 micro and 1.8 micro is the minimum requirement. You remove these 2 layers, delete this, go delete, press delete after selecting. Now you select P select, because here you want P plus. Click here, then press R. Okay, we have P select, then we should have N select, because this N select is there to have a connection with the N well. Okay, right, now go to N well, then take 6 units away from this active, 1 2 3 4 5 6, that is for good DRC. So click there, press R, okay, now our Pmos is ready, and zoom out, go here, fit to screen, click here. Now Pmos is ready. Now I want to verify the DRC whether I have made any error on the design rule check. Go here, run it, take the DRC file, go to ENGR, we have DRC file there, click on that DRC file, open it, then click OK. See, it is showing no DRC errors were found. So our design is good, we don't have any DRC errors. Now see, I'm selecting this, press M, I am moving this over the metal contact. Okay, now I am again verifying this, run DRC, that file is already there, click OK. Now see, it found 9 DRC errors. So if you want to see that DRC error, go here and view errors. So it will show the overlap of poly contact, that thing, exact poly contact size is this thing, that and all. So from that we will get the information about DRC errors what we have made. Now go here, go to DRC, clear errors. Okay, now it will clear the error, then press M and move to previous structure. Okay, this is how you can create the Pmos. After that, go here and save, go to save library and save to directory. Don't forget to save our things I'm going to save here in result. Okay, select the folder, give OK. Okay, in the next video I will tell you how we can draw the inverter and how we can do the post layout simulation for that inverter. Thank you.